Module 12, Lesson 8 covers volumes of spheres. The textbook is claiming this is a one-day lesson, but they're also giving us 16 resources to get through, so I kind of have my doubts on that. In basketball, the age of the players on the team or the league determines the size of the basketball that's used during the games. Basketball sizes are given in terms of circumference and the largest circular cross-section of the basketball. Children 9 years old and younger use a size 5 basketball, which has a circumference of 27.5 inches. The next two sizes, 6 and 7, have a circumference 1 inch greater than the previous size. Moving forward from there, it says, think about the amount of air in each basketball holds. How do these amounts compare to one another? Well, you can see that actually, they don't show that. They just show radius and circumference here. But the bigger the ball, obviously, the more air is going to be needed. How to calculate how much air is going to go into it, that's part of what we're going to be learning about in today's lesson. We're going to start off by defining a sphere. This is another definition that you should already know. A sphere is defined as a set of all points in space that are a given distance known as the radius from a given point known as a center. So you take that center point inside of that sphere, inside of that ball, select a distance all the way around it that's the same, and fill it in solid, and that's what a sphere is going to be. In words, we have for the volume form of a sphere, we have volume of the sphere is equal to 4/3, that's different, the product of pi and the cube of its radius. That's different too. We've only been squaring our radiuses so far. Looking at the sphere as a model, you have your center point, and the same distance goes all the way around in all directions, makes a sphere. And then finally, the formula written as a formula, volume is equal to 4/3 times your radius cubed. Of course, I should be saying this on all these videos. The first thing you write on each and every problem of your assignment should be your formula. This is what's required for credit, and it's what's required for you to memorize that formula, so it'll be there for you. So let's find the volume of this sphere that has a radius of 6 centimeters. That's the only information we need to know to plug into our formula. So we're going to see if we can zoom in a little bit so y'all can see a little better. We have the formula written first, the first thing you write on every problem, and then we're going to take and plug in what we know. We know that the radius wasn't it 4? Nope, it was 6. So the radius is going to be 6. And now from there, we're going to have to take and cube 6. So 6 times 6 times 6. Well, 6 times 6 is 36. Times 6, that's going to be 180 plus 18 is going to be 198. And then they took right there and multiplied that 198 times 4/3. You know, let's just take a moment and do that off to the side. So we're going to take and grab this part right here. We're going to jump over to our scratch page, and we're just going to actually look at doing that on our scratch page by hand so that we're confident you understand where the numbers are coming from. First of all, I did the volume here is going to be equal to, I'm going to leave that 4/3 alone, and I'm going to leave pi alone, and then 6 times 6 is going to be 36. 36 times 6 I said was going to be 196, but let's grab a calculator and check my math, see if I did it right in my head. 6 times 6 times 6 equals, whoa, no, let's try that again. 6 times 6 equals, times 6 equals 216. I was not right in the math in my head, so we erase that, and we're going to take and put in the 216 instead. And from here, we're going to take and rearrange it. I'm going to say volume is equal to 4/3 times 216 over 1 times pi. I'm going to simplify if I can, which I can, because 2 plus 1 is 3, plus 6 is 9. 9 is divisible by 3, so I know the whole thing is. 3 is going to go into 3 once, and 3 is going to go into this 72 times. 3 went into 21 7 times, nothing left over. 3 went into 6 2 times. Next thing we're going to do is we're going to multiply the 4 times the 72. That's going to be 280. Plus 8 is going to give me 288 times pi, and that is where they got the number that they put right here, 288 times pi. They just did a whole lot quicker than I did. Last thing we're going to do is going to be to take and, let's see if how they want us to actually write that one. I'm going to say, well, they give us that option, so we're just going to type the 288, hit geometry, hit our pi button, accept, and check, and a check. They did not even want us to multiply it by 3.14 or pi on the calculator. Your turn. You've got a sphere that has a diameter of 22. Be careful there. You find out the radius and then the volume, express it in terms of pi. Alright, I put in my formula. I'm going to put in what I know. Volume is equal to 4/3 times pi, and my radius is going to be 11. Okay, so I'm going to have 11 cubed. The radius is half that diameter. Now, I know 11 times 11 is going to equal to 121, and 121 times 11 again. When I do that, I'm going to take and do let's see if I can do this and use a trick on it. The way that 11's rule works is when you have a pair of numbers like this one, 11 times 11, I'm going to take this one, put it here, this one, put it here, and then add up what's between them. 1 times 1, 1 plus 1 is 2. That's where the 121 came from. Now I'm going to do the same thing again, but it's going to be a little more exciting. This one is going to go on this end. This one is going to go on this one. I have 1 plus 2 is 3. 2 plus 1 is 3. So my answer, volume, is going to equal to now 4/3 pi times 1,331. Now I know that seems a little crazy, but let's go ahead and look at it in the calculator. And on my calculator, I did 11 times 11, which gave me the 121, times 11 again, and that gave me the same number I just came up with using my 11's trick of 1,331. Now we're going to take and rearrange things. Volume is equal to 4/3 times 1,331 over 1 times pi. Nothing's going to simplify here. Take a little bit further. Volume's going to equal to, multiply 1,331 times 4, and that's going to end up giving me 5,324 divided by 3 pi. That I'm going to have to change into a mixed number, so I'm going to do some long division. 5,324 divided by 3. 3 goes into 5 once. 1 times 3 is 3 with 2 left over. Bring down the 3. Next number is going to be 7, which is 21. Bring down the 2. Next number is going to be 7 again, which will be 21 again. Bring down the 4. And then finally, it's going to be a 2, which is going to be 14. So I'm actually going to be, did that divide out perfectly? No, it didn't divide out perfectly. I had my head where it didn't need to be. So let's try this again. So I'm going to bring down the 4. For some reason, I put 7 in there. 3 goes into 14 4 times, which is going to be 12 with 2 left over. So my answer, volume, is going to equal to 1,774 and 2/3 pi. Let's go ahead and plug that into our answer key over here. It's going to be 1,774 and 2/3, and geometry, pi. We're going to hit accept, and we're going to hit check. Uh-oh. Alright, that's not even fair. They decided that they weren't going to change their improper fraction into a mixed number. Have we ever not changed the improper fraction into a mixed number? I don't think so. My answer was correct. They just got lazy at the last minute on theirs. For example 2, you have a spherical stone found in Costa Rica that has a diameter of about 8 feet. Find the volume of the spherical cone and round it to the nearest tenth. What's the relationship between the radius and the diameter? Well, the radius is, of course, going to be half the diameter. So this is the same basic type of problem we worked before, only this time they give us a diameter and we're going to have to find the radius before we get into it. So we're going to take and plug in what we know. We know that the radius of the diameter was 8. The radius is going to be 4. Check that. That works. Next, I'm going to take and say, well, they did a whole bunch at one time, but 4 cubed is 64. That's 4 times 4 is 64. 4 times 4 is 16, times 4 is 64. And then they took that 64 times this 4, and that's where they got that 256 over 3 from. And so they have 256 times pi. From here, they took and look at that. They used a calculator on that one, multiplied it times pi, divided by 3, and we got the 268.1. So the sphere is going to be about 268.1 cubic feet. Hold on. The volume of the sphere. Let's check and see what they did wrong, because I just typed in exactly what they said. Round to the nearest tenth, find the volume of the spherical stone, round to the nearest tenth. They just did that right there. They even told us what the answer was. And what are they saying the answer is? Oh, I typed in the wrong number. Yep, I did 3 and they did 2. Dang it. Time for you to do extra example 2. Take your time, do it well. A dish contains a scoop of ice cream resembling a sphere with a, there it is, a diameter of 6.4 centimeters. So we're going to have to find the radius of that. What's the approximate volume of the scoop of ice cream? And also we have right here to use the pi button on the calculator and then round our answer to the nearest tenth. So let's get started. Volume is equal to 4/3 times pi times the radius cubed, which means volume is equal to 4/3 times pi times, and half of 6.4, that's going to become 3.2 cubed. Next, volume is equal to 4/3 times, and I'm going to do a couple things at once. I'm going to find out what 3.2 cubed is, so I'm going to take and put in, I'm going to use a different trick on the calculator to do this. 3.2, I'm going to hit that x to the y. What's my y value? 3, because we're cubing it, and that's going to end up giving us 32.768. So I have 32.768, and then I'm just going to put pi on the end of that. Now we're going to take and multiply and divide some here. So I'm going to, in doing this, I'm going to do the 32 whatever times 4. That's going to end up giving me 131. What was that? 0.072 pi divided by 3. And now when I take and finally finish that math out right there, I'm going to have the volume is equal to, I'm going to take that number, divide it by 3, equals that, and then I'm going to multiply it times pi, which is going to give me, to the nearest tenth, 137.3. 137 3/10. Jump back over to our textbook, type in our 137 3/10, and hit our check button, and it checks. I like it when it makes that sound. Now this lesson's taken a little longer than I hoped, but exactly as long as I expected, so I'm going to go ahead and stop the video and come back and watch part 2, where we're going to continue our study into the volume of a sphere.